synthetic division, what we want to do is we want to divide out this factor using synthetic division. So we're taking this x minus 5 and dividing it from this polynomial. You can't do synthetic division with every set of polynomial dividing another polynomial. You must have it in the form of x plus or minus some number here. And that's what this form is in. So the first thing we want to do is we want to take that blue equation and solve it for x. So I'm going to add 5 to both sides. So I get x equals 5. And we're going to use that number in just a little bit. The next thing is to go ahead and set up a box. And we're going to use the numbers in the red to help us. I'm just going to bring this box up a little bit here. All right. So the first number we want to use is 3. So that's going to go underneath the x cubed placeholder. Then negative 17 is going to go under the x squared placeholder. And then 15 is going to go under the x placeholder. And then negative 25 is going to go under the constant placeholder. You have to make sure whatever your degree is, in this case it's a cubic, you're going all the way down to the constant. So you're going to have an x cubed, an x squared, an x, and a constant. So you're just taking those coefficients and then the constant. Now this x equals 5 is going to come down and go in front. Now you may want to pause and just watch this next process. All right, so here's the setup for synthetic division. Now we're going to solve it. So the first step always is to bring down that first number, 3. And everything underneath this box is going to multiply to 5. So I say 3 times 5, and I get 15, and that's going to go in this placeholder. All of the columns, so I would say this is a column, is going to add. So negative 17 plus 15 is negative 2. Now again, that's underneath the box, so now that's going to multiply to 5. So negative 2 times 5 is negative 10. Goes right here. Now I add the column. Negative 15, positive 15 plus negative 10 is a positive 5. Now I multiply that blue 5 to the green right over here. 5 times 5 is 25. Now we add the column. Negative 25 plus 5 is 0. What we're hoping for is that last number in the yellow here to be a 0. So what we've done is we've synthetically divided out the factor of x minus 5. Now, we started off with the cubic, so we're going to drop this by 1 degree. We're left with now 3x squared, negative 2x, constant, and remainder. So your answer then is 3x squared minus 2x plus 5. This is your answer. That last number is your remainder. You could check the solution if you wanted to by evaluating it for 5. I don't recommend it, but you can if you want. So let's practice doing another one. We want to use synthetic division to factor x minus 4. So the first step is to take this factor that you're dividing and solve it for x. So we're going to add 4 to both sides. And we get x equals 4. So that's the number that's going to go out in front. Just going to bring this box up a little bit here so I have some room. All right. So now, here is my 5x cubed. So my placeholder is x cubed, and I have a 5. There is my negative 6x squared. My placeholder is negative 6. And then notice right here, I don't have an x. So that means there has to be a 0 right there. And then the last one is my constant, which is positive 8. Now my 4 is my number out in front. All right, so now we're ready to do our synthetic division. The first step with synthetic division is to bring down that first number, 5. Now we multiply. 5 times 4 is 20. Now add the column, add these two numbers together. Negative 6 plus 20 is 14. Multiply 14 times 4 is 56. And the column, 0 plus 56 is 56. Now multiply 56 times 4 is 224. Add the column, 8 plus 224 is 232. That's your remainder. So now since we started with an x cubed, we're going to drop it by a degree. So now it's going to be an x squared, your x, your constant, and your remainder. So your answer then is 5x squared plus 14x plus 56 plus a remainder of 232. If you find out, you don't need to write this down, there's this thing called the remainder theorem. If you get a remainder that is going to be f of c, if you evaluate it, that will be your remainder. So if you're evaluating, like say f of 5, whatever you get out when you evaluate it will be your remainder. If you wanted to read more about that or practice it, there's a video here or a practice setup if you wanted to do that. If you don't get a remainder, and that's this next piece is talking about, if your remainder is 0, then it is a factor of the polynomial.